Right now, outside your window, there is exactly one sun. It rises, it sets. Your entire life runs on that rhythm, but somewhere out there, on a planet not so different from yours, a person is watching two suns sink below the horizon at the same time. And the real answer to what that would do to a world like yours is far stranger than science fiction ever imagined. You have probably seen it in a movie. A young farmer looks up at twin suns and dreams of leaving home. It feels like fantasy. It is not. Astronomers have already found planets orbiting two stars at once. They are called circumbinary planets, and one of the first ever confirmed was Kepler 16b, discovered in 2011 by a team including astronomer Lawrence Doyle. It orbits two stars that circle each other every few weeks. Real data, real orbits, not a movie set. So what would happen if your planet, the one under your feet right now, orbited two suns instead of one? First, forget the postcard image of two identical suns split evenly across the sky. That almost never happens. Binary star systems come in wildly different configurations. Sometimes the two stars are close together and similar in size, so they'd appear as a tight, blazing double disk. Sometimes one star is small and dim, a faint red ember next to its brilliant partner, barely noticeable except at dusk. Your sky would depend entirely on the geometry of the system you were born into, and that geometry would decide almost everything else about your life. Think about your calendar. Right now, your version of a year is simple. Earth circles one star. 365 days, one loop, done. A two-star system breaks that clean loop. If your planet orbited both stars together, like Kepler 16b does, your year would still be somewhat regular, just longer or shorter, depending on the mass and distance of your two suns. But if your planet orbited just one star, while a second star swung around at a distance, your seasons would stack on top of each other in strange overlapping rhythms. Some years, both suns might blaze high in summer at once, roasting the surface. Other years, they might separate, giving you two smaller summers instead of one. Your ancestors, whoever they were, would have needed a wildly different kind of calendar. Not a simple circle. A tangled, layered orbit chart tracked across centuries. Here is where it gets stranger. Nights would rarely be fully dark. If you have ever tried to sleep during a full moon, you already have a small taste of this. Now, imagine a second sun always glowing somewhere near the horizon, even after the first one sets. Astronomer René Heller, who has studied the habitability of planets in binary star systems, has pointed out that depending on the orbital configuration, a circumbinary world could experience long stretches without true darkness at all. Your body clock, the one shaped by billions of years of evolution to expect a dark night for melatonin to rise and sleep to deepen, would have to adapt to something your ancestors on a one-star planet never faced. Would you even develop the same sleep cycle? Would night, as you understand it, exist at all in the way you experience it now? Your body is not the only thing shaped by a single sun. Your seasons, your crops, your migrations, all of it is tuned to one predictable light source. Take that away, and the entire evolutionary logic of your biology shifts. On a world with two suns of similar brightness, plants might evolve to photosynthesize from two different light spectrums at once, since each star could burn at a different temperature and color. A star cooler than yours glows red. A star hotter burns blue-white. If your planet sat between two such stars, your plants might be adapted to squeeze energy from both ends of the light spectrum simultaneously. What color would a forest be under two suns? Not necessarily green. Green exists on your planet because plants reflect the wavelength your single sun does not favor for photosynthesis. Change the light source, and you change the fundamental color of a living world. Now think about your shadows. Right now, you cast one dark, sharp shadow behind you. With two suns in the sky at once, you would cast two shadows, layered and shifting, sometimes overlapping into total darkness, sometimes splitting apart into two separate silhouettes as the suns moved independently across the sky. Something as simple as walking outside at midday would look completely different. Time itself, the way you read it from the position of a shadow, would become ambiguous. Sundials would not work the way yours does. You would need an entirely new way to measure the hour. there is a darker side to this too. Multi-star systems are not always gentle places for a planet to exist. The gravitational tug-of-war between two suns can destabilize orbits, fling smaller planets out into the cold of space, or pull them into their stars entirely. Researchers studying planetary formation in binary systems, including work published by teams associated with NASA's Kepler mission, have found that many binary configurations make it far harder for a stable, life-supporting planet to survive in what's called the habitable zone, the narrow band of distance where liquid water can exist. Your planet, the one that gave you oceans, rivers, and rain, sits in a remarkably fortunate zone around a single stable star. Two suns competing for gravitational dominance would have made that stability far less likely. In a very real sense, part of the reason you exist, breathing and reading this right now, is because your solar system only had to balance one center of gravity, not two. And yet, some circumbinary planets do sit in stable, habitable zones. Kepler 16b itself, though a gas giant unlikely to host life as you know it, orbits within a region where temperatures could theoretically support liquid water on a rocky moon if one existed there. Scientists have not stopped searching. The hunt for a genuinely habitable two-star world continues, because if one exists, the life that evolved there would carry the fingerprint of that double light in its biology, its rhythms, its color, its entire relationship with time. Here is the part that should genuinely unsettle you. If a civilization ever did rise on a stable circumbinary planet, their entire concept of what is normal would be built around two suns, the same way yours is built around one. They would not marvel at their sky. They would take it completely for granted, the same way you take your single, quiet sunrise for granted every single morning without a second thought. Their myths would explain two suns instead of one. Their gods would fight, chase, or dance across a double sky. Their poetry, their science, their entire mental model of what a normal planet looks like would be shaped by a sky you would find almost incomprehensible, and that reframes your own sky entirely. The single steady sunrise you barely glance at each morning, the one clean shadow behind you at noon, the total darkness that lets your body properly rest each night, none of that is the default setting of the universe. It is one specific, almost lucky outcome out of trillions of possible planetary skies scattered across billions of star systems. You are not living under an ordinary sun. You are living under a rare and stable kind of quiet. So tonight, when the sun goes down and the sky goes properly, fully dark, you are experiencing something that is not guaranteed anywhere else in the universe. You are living the version of reality where one star was enough. Somewhere out there, under two suns, someone else is living theirs. And the real answer to why your world feels so simple is that it was never simple at all. It was just one very fortunate roll of a cosmic dice, spinning quietly under a single steady sun.